Morning, everyone. My name is Timothy Lee Grant, and today we are going to do a fun little game. Fun. It is called Leetcode. So let's go. All right. Which problem are we going to select today? Let's try. Should we close our eyes and pick one? I like that idea. Let's do it. Okay, so I have my pointer here. This one. Whatever this one is. Tree. Okay, cool. All right. Now, we pick the next easy. Okay. This one. Diameter. Let's go. 543. Diameter of a binary tree. Given the root of a binary tree, return the length of the diameter of the tree. The length of the diameter of the tree. What on earth is that supposed to mean? Hold on. Let me reread this sentence, figure out what it might be asking. Given the root of a binary tree. Okay, we're given a root. Very good. Return the length of the diameter of the tree. Thought I needed to sneeze. I guess not. The diameter of a binary tree is the length of the longest path between any two nodes. Okay, so it's like that. The longest path. Okay. Between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes represents the number of edges between them. Okay, so this one right here, we have this equals 3, and that's 1, 2, 3. Okay, so there's one edge, there's two edges, there's three edges, and that's one path. Okay, so great. How are we going to do this? Oh, I don't know. I don't know how we're going to do this, but let's try. I'm going to have a sip of water. There we go. That ought to help me figure this problem out. Water power! Let's go. Okay, so what do I want to do? It's recursion, right? Because that's how we're going to be traversing the tree. So I know that I need some kind of recursion. So def traverse. Okay, that's normally how we do it. And we do it on a node. And then I'm just going to say pass because I don't really know what we're going to do yet. So then I know traverse. We normally do that. And then pass in the root. And then we return something. Length. Length. Yeah. Okay, so that implies that we need a length. So length equals 0. Okay. If not root, return 0, right? Because if there's no root, there's no edges between them. So let's do that. Okay. Actually, I don't even think we would need that because if we do root, we're already at a base case, and so we need a base case. Let's do the base case. If not node, return. There we go. Okay, we got a base case. Do we need this? Maybe, maybe not. We're going to return this. Now, this is length. Do we need to update it? So this would have to be a non-local length. Okay. Now, how do I want to do this? Maybe I should have put more thought into that before we started coding, but I didn't think that far, so it's fine. So we're going to have this, and we're going to go down one. Okay. We're going to go down one. So, for example, this, let's say that this was really long down here. We could have something that was from here all the way down here and then coming all the way down there, and that would be a path. I feel like I've done this problem before. I feel like I've done something very similar. I don't know if I did this exact problem or what, but I feel like some time ago in the past I did this problem. Does it say attempted? It doesn't say attempted, so I don't know what's up. But anyways, so what? So I need to keep coming down. And I know that... Okay, so I'm going to think from the perspective of this node right here, that 2. I want to know... I'm going to be able to get the length from all the way down here. That's going to be my left length. And I know that I'm going to be able to get the length all the way down here. Okay, so that's the like largest length. So, for example, this node, this 1, is going to be able to look, and let's pretend that this 5 is not here. Okay, so it's going to, actually, let's pretend that the 5 is there. But there's another 1 down here. So like 4 is connected to something down here. So this 1 is going to see 1, 2, and then 3. So it's going to see a 3 from its left, and it's going to see a 1 from its right. So that is like the maximum path down on that tree from the left and from the right. Now, what is the option? So we're back at this 2. So I see the longest length down all the way up down to some node down here. And that is given to me from this node. So it passes up its longest length. Okay, it passes up its longest length. So I know that I am going to need to down here, I know that I'm going to need to return the longest length, right? So longest path down. And what is the longest path down? So let's say that this one was way down here, and this one here was really short. It was just that 5. So from this 2's perspective, what is it going to pass up? Up here to the 1. It's going to pass up to the 1, its longest one, which is the left path. So I know that I need to go left and I need to go right. So left distance equals traverse node dot left. Okay, right distance equals traverse node dot right. Okay, so I'm going to get the distance, which is the longest down, and that comes to me from here, my left distance, and then the longest distance path down from my right. And I need to make a decision. Am I going to pass up the left, or am I going to pass up the right path? Okay, so I'm actually going to return the maximum, whichever one is bigger, of left distance or right distance. So I give the one that's largest. And then I also know that I need to add 1 because I'm going to take this edge into consideration, right? Okay, so plus 1. Now I'm not liking this base case because this is just a return. It's not returning anything. So if I'm here at this 4, I go and I try to access a node down here. What do I want it to return? Like, I get this 4, and what is this down here? It is 0, right? It's 0. So I want it to just return 0. Yeah, because my distance down from my left path is 0. There is no distance down there. What do I want right to return? 0, because it's none, right? So once I pass in a null, I want it to give me back 0, so just say 0. So then from this perspective of the 4, I'm going to get 0 and 0, and then I am going to take the maximum, so 0 and 0, so 0, 0, right? So, and then plus 1, 1. So now 2 says, okay, what is the longest length path from my left side of the tree? Well, it's 1, which corresponds to reality. So I think we're on the right track here. And same thing is going to happen from here. Now, that should give us the longest path from, like, looking down. But we want to find the diameter, which means we don't want just the longest path. It's this way, up here, and like that. Because we can also go all the way up, and then we can start going down, right? We can go from here, or actually it would be down here, up to here, up to here, up to here, and then not just stop here. From this 1, we have to look, well, what is a path? It is from here and then down to the left or to the right child. So we can go all the way down here. So, I didn't mean to do pages. No thanks. So, how do we want to accomplish that? Well, we have the distance of our left, and we also have the distance of our right. That's the maximum distance down on our left and the maximum distance down on our right. We can just add that together to see at each node what is the maximum distance that we could go if we were to choose to go down that and direct the path from our left over to our right. What is the maximum at that node? At this node, what is the maximum? It would be we get a 1 here and we get a 1 here. So it's a pathway of 2 if we were to redirect from the left to the right. But if we come up here, that's 1, and then up here, that's also a 1. So now we have 2, and then redirect it to the right, that's also a 1, right? Because this is going to return up a 1. So it's the left plus the right. So how do I want to do that? I'm going to be changing this length, right? So length equals max. I want to take the maximum value of the current length and left distance plus right distance. Now, do I do any right distance plus 1? Well, no, because look, what is that corresponding to? It's going to be all of this all the way up here, okay? And I just got back from this 4, its length, and it was including this edge. And I got back this 5's length, including this edge. So what is the longest path? It is just whatever I got up from this 4 and whatever I got up from this 5. I take those, add it together, and I say, okay, which is longer? The current longest length right here. So actually I want to delete that before I... So what is longer? The current longest length that I have saved at right now, it's at 0, or if I redirect it. So it's going to be redirected here, and then we're going to update length to be 2, right? This one redirected here to 2. Then we're going to pass up. What are we passing up? We're passing up 2, not the longest length, because that includes traversing down here. We're passing up 2 because it goes 1, and then we do the maximum. So we have 1 and 1, and then we take the maximum of that, which is just 1, and then add 1, right? That's what we're doing here. So that's 2, so we give 2 up to this 1. So that corresponds to 1 edge, 2 edges, okay? Then this 1 gets back a 1 from here, so we have 2 and we have 1. So that's what this node here sees. And it says, okay, I got back a 2 and I got back a 1. Now I'm going to take the maximum right here. So I'm going to try to update length. I'm going to take the maximum of the current length, which what did we just say we changed that to? We changed it to 2. So I'm going to update it to be the maximum of 2, or my left distance, 1, 2, right? Plus my right distance, 1. And that corresponds to coming up here, and then redirecting it down there. 3. So which one is bigger? It is that 3. So that's why we are going to update length and get that to be our value. I think this will work. Do we want to try it? Let's press that submit. It's going to be funny if it doesn't work because I said it so confidently. And it worked! All right, wow. Okay. Nice, awesome. Okay. All right, well, thank you guys for watching this video. If you liked it, please subscribe. That would be amazing. I have like 550 subscribers now, so thank you to everyone who subscribed. That is amazing. And I will see you guys tomorrow with another Leetcode problem. Yeah, thank you guys for watching. My name is Timothy Lee Grant, and I will see you tomorrow.